Hey everybody, it's Joe, and I am back from the East Coast RepRap Festival, or EARF for short. While I was there, I collected some more ornaments for the Christmas tree. Thank you guys very much. I also collected some more maker coins, and I think I'm going to go ahead and put these on the Christmas tree too. I think that that would be a perfect addition. It was an amazing event. I met so many absolutely wonderful and amazing people. It was a thrill to meet every single one of you, and thank you guys for being there. Some of you might not know the circumstances surrounding me getting to Earth. It was a little bit unusual. My plan this year was to go to the Midwest RepRap Festival and the Bay Area Maker Fair and call that it. That was the only travel I was going to be doing this year. But after I went to the Midwest RepRap Festival and saw so many amazing things being done with 3D printing, all of which stem back to the RepRap project, which was created by Dr. Adrian Bowyer in England, I just kind of sent out an offhand tweet and said, has Dr. Bowyer seen what people has done with this project that he started so long ago? He should come out to these events. And he replied to my tweet and said, yeah, I'd love to if you guys could help me out. Now, the people who organize Earth contacted me and said, how did you get him to do that? We've been trying to, the Midwest RepRap people have been trying to pin him down for a long time. And I went, I don't know. I just sent out a tweet. I don't know. It's just a thing. And they said, well, don't worry about it. We got sponsors. We'll get him here. You don't have to worry about a thing. We'll see you there. And I was like, but I wasn't, that wasn't, I guess I'm going to Earth now. And so I had to make arrangements and get myself there. And of course, it was Chibimals that got me there. It was the money that I raised from Chibimals that I used to go there. So thank you very much, everybody who backed the Chibimals project. Now, I've got a lot of videos that are just coming due right now. I've got hardware reviews. Of course, I've got to finish up my Blender 2.8 tutorial series. And of course, I have my not Lego, but interlocking brick videos that I need to finish, including videos about how to print them. But I'm also going to include a video about how you can make them because they can't take down what's in your head. So that is coming, but all of these are happening at the same time. So this video I felt I needed to get out right now because this video is my interview with Dr. Bowyer. He was very kind to remember me and sit down with me and let me just talk with him. I should have spent more time at some of the bigger vendor booths because Prusa just released a Prusa Mini, which I've got opinions on, and they're all good. I absolutely love it. And I should have talked to Protopasta, but I mostly focused on the people and the projects and the things that they were doing with 3D printing. And so those are the videos that you're going to see from me from the East Coast RepRap Festival. So without any further ado, this is my interview with Dr. Adrian Bowyer. I think at the end, I'm just going to call this a conversation with Adrian Bowyer because
Bowyer.
Yes, Bowyer. It's going to take me forever to get that right.
I don't know why my name is really easy for me to pronounce because
well, you've been practicing your whole life.
Yes,
Dang, you beat me to the joke.
Sorry. Yes.
No, it's a good one. Hey everybody, it's Joe, and I am hiding out in the green room, which my. Can I call you my good friend?
Yes, we've never met, but I'm sure we.
I'm sure
we're not already.
We will get on famously.
Yes.
This is Dr. Adrian Bowyer. Did I get it right that time?
You did.
Oh, fantastic! And for those who don't know, this is the man who was in the right place at the right time and said, let's take this idea of a 3D printer, and the patents had expired. Did that calculate into your...
Not quite. They had 3 years to go, but it was a 3-year research project, and in Europe you're allowed to research patented technology without paying any royalties. So
there you go.
No problem.
Who said, let's make a self-replicating rapid prototype machine, and the RepRap project was born. Now, you gave I felt absolutely, I did not expect to be as
as moved by this presentation as I was.
Thank you.
Because I felt like I kind of knew what to expect from you, and you surprised me. It feels like you've still got more to say on this subject after all this time.
Thank you. Yeah, yes, I'm not sure if what I said was... I don't know. I can't judge myself, but there's no point in standing in front of people and telling them this is how a 3D printer works at a 3D printing festival, because everybody here knows how 3D printing works.
Well, but I wanted to talk about the
social and economic. Sorry, go on.
No, yeah. I kind of knew how this whole started, and I expected you to talk about, yes, here's the beginnings of the project, but you didn't. You talked about the economic impact of this. You talked about the environmental impact of 3D printing. It was inspiring.
Thank you very much. And I broad but shallow range, I think, is.
This is the perfect venue for broad but shallow.
Okay.
Really. And then you went on, and you're still thinking of new ideas for how to do rapid prototyping, and I was rather inspired by your idea. I'm not sure it will work, but I don't know if you're sure it will work.
No, yeah. I have no idea whether it's going to work in practice, physical reality or not, because it's an idea I had very recently, only a couple of months ago, and so far all I've done is to write a simulation of it.
It's
a mathematical.
It's basically an EKG backwards. Is that what it is?
Yeah, sort of. Yes. So a sort of combination of EKG and CT scan backwards. Right. So the idea is that you have a vessel full of a liquid which will react to an electric current, and you pass electricity through it in a complicated pattern, with the idea that the liquid will become solid in just the places you want.
Right, and just like a CT scan runs electricity through and reads the difference.
Well, in a CT scan you're running
CT scan,
X-rays, but yes,
right.
The same principle. Yes.
Right.
The nice thing about X-rays is they go in straight lines, and the annoying thing about electricity is it'll go everywhere if it's got an electric.
That's the problem. Yeah.
So that's what makes the thing complicated and possibly even unworkable. You can say until someone makes one.
I do like you mentioned Berkeley's where they're running light through an oxygenated polymer so that it burns off the oxygen, and when it burns off enough of the oxygen, it solidifies.
Yes, it's either that or the other way around. It either releases oxygen and it solidifies, or it takes it away and it solidifies. I can't remember which, but one or the other.
And they take that and they rotate it around, creating the full 3D. And my problem with that has always been that they're rotating a liquid. And liquids like to move and sway.
Indeed, yes, that's true. I think what they do is they set it spinning, wait for it to settle at a constant rate, and then fire up the process. Don't remember that from the paper. That's pure speculation on my part, but if I were doing it, that's how I'd do it.
Yeah, well, and I'm not sure that they are, because I look at the prints and I'm like, that looks a little inaccurate. Maybe they're not doing that.
Yeah, maybe.
The way I would do it is I would move the camera around the machine and just hold the liquid steady, So,
yeah, you could do that, yes. Yeah. No, you could do that with their system.
The problem is you're moving a large camera.
Object. Yes, but
well, I suppose it gets suspended above and move the mirror around or something.
Mirror. Yes, 45-degree mirror would do it.
Actually, now I'm thinking about that. Couldn't we have a parabolic mirror, just project down into it and have it all go in the same direction? That would almost be your solution.
Almost. No, because you need an entire, well, not an image, but you need an entire pattern of light. You could do it with a single beam. In other words, you could do it with a single laser, but it would take forever, because you've basically got to fire the laser everywhere in 3 dimensions, and you assume you've only got one laser. It's going to take a long time.
You would need at least 3 lasers to get 3 dimensions.
Well, you might be able to do it with one, as long as you're prepared to move it around enough and take long enough over it. But their system uses a projected 2-dimensional image, which is like however many pixels it is. Let's suppose it's 1 million pixels, 1,000 by 1,000.
The 4K even.
Or whatever, yes. That's like having 1 million lasers all at once pointing into the liquid, so you go 1 million times faster.
Yeah. No, I also enjoyed, we were talking a little bit before I hit record on it, and I was like, we got to record this conversation. I've done videos in the past talking about how STL is just not acceptable as a file format in so many ways. I was mentioning floating point errors, but there's more than that.
There's the fact that it doesn't ensure that the thing is topologically solid. doesn't ensure it's geometrically solid, which is a subtle distinction, but nonetheless there is one. And yes, it's a disastrous format which we're stuck with because it's become established and therefore universal. And so there's an awful lot of software out there which is designed to patch it up and get around all the problems. But if you were starting again, you wouldn't start from there, or you wouldn't go there. Yeah.
I mean, my big complaint about it is that it's unitless.
Yes.
You know, it one unit in an STL is 1 watt. And we assume it's millimeters, but then Autodesk grabs it and they're like, yeah, we're American, we do it in inches, you know.
Yes, yes.
Which just exacerbates the floating point problems when you get
yes.
Well, actually, it could make it better because it covers more of a distance, I guess.
But then if you want an STL or something on the scale of a microchip,
right?
Yeah. Anyway, yes.
No,
it's not a good format. I'm a mechanical engineer, and it was probably designed by a mechanical engineer, not a computer scientist. And there are rival formats which do much better. The triangulation format, the authors of which I apologise to, but I've forgotten, where you
don't have to cite for a YouTube video. Come on, right?
But I like to get these things right. I like to acknowledge them when they're done well. But yes, instead of STL format, it's just a list of triangles, which means, for example, every vertex is multiply represented. We've got six
for every polygon that bumps up against it, that vertex has to be repeated.
Yes, much better just to have a list of vertices recorded only once, and then a list of triangles. Where each triangle consists of pointers to 3 of the vertices,
right,
and then pointers across the edges to 3 of the triangles that are adjacent to the triangle you're considering. And if you ensure that the pointers to the triangles are opposite corresponding vertex, the topology of the whole thing is then completely
watertight.
Yeah. Well, literally watertight in the sense that there are no holes. Yes. Yeah. And of course, the Euler-Poincaré formula will then tell you whether it really is a solid or not. And so that would be a significant improvement.
It's a solved problem.
Yes,
we understand.
It was solved when the STL format was invented, but except the person who invented it didn't do their research.
And I mean, we can have this conversation now and look back and go, they have no idea what they're. But the fact is, they got the job done. You know?
They did get the job done, but the knowledge to do it right was available when it was done wrongly.
It
wasn't as if they were working in the dark.
For sure, but at the same time, nobody can be an expert in all things.
But everybody can use a library.
That's true. That's fair.
Yes.
That's entirely fair. No, 100%. So, and I asked you this: what have you seen people do with 3D printing since you put this out there?
Mm-hmm.
And you mentioned that people doing what was it?
Yeah. Well, the example that always sticks with me, I put this machine out there, and being an engineer, I expected people to use it for engineering. I expected them to make microphone holders and that sort of thing. And sure enough, they did. Here's the prime example. But some things took me completely by surprise, and the one that took me most by surprise was when I found that somebody had designed a seashell and 3D printed it, or in fact 3D printed a lot of them, and dropped them in the ocean, and then had discovered that hermit crabs had taken up residence. So he had all these hermit crabs wandering around with Day-Glo shells on their backs. Shells. Yes, 3D printed shells. That's and of course the hermit crabs got a home, and we all got to see something which was extremely surprising and almost so surprising a thing that it was almost a work of art. You know, yes.
I think it was. It was. Now it's funny because you talk about using 3D printing for engineering stuff, and I think that my wife, who is not into 3D printing, she sees me 3D print, fun but otherwise useless crap.
Yes,
and has something to say about that. Mm-hmm. What's your opinion on that? Do you see people printing useless crap, and you're like, "Come on, God, this isn't what I invented this thing for"?
No, I would never dream of telling anyone they shouldn't print something. Well, another point I made in my talk is that when you're running one of these machines, let's assume you've got it connected to the worst and most polluting of coal-fired power stations. You're putting, as you're running the machine, you're putting 8 grams of carbon up the smokestack of the power station every hour.
Right.
But in the plastic you're printing with, you're laying down as a permanent solid 25 grams of carbon, which means that you're 17 grams ahead of the stuff going up in the atmosphere. Now, if the carbon you're laying down came out of the atmosphere, then
because it's a plant-based polymer.
Because it's a plant-based polymer and all the carbon in a plant comes out of the atmosphere, then what you're doing is you're taking 17 grams of carbon an hour out of the atmosphere and locking it away in a solid. And so environmentally, the technology can be quite benign. And if you do the calculations, it turns out that all the non-3D printed parts of a RepRap machine, which obviously have some sort of carbon load when they're manufactured.
For sure.
If you run the machine reasonably intensely for less than a year, you've offset all the carbon that went into the manufacture of those bits as well. And after that, you're all net positive.
So 3D printing is going to save the environment. Wow.
Well, no, but nonetheless, and you've got to be a little bit careful with the thing you printed. I mean, if the thing you printed either gets burnt or gets dumped in a landfill where it gives off methane, then you're in a worse position than you thought you were. But as long as you print junk, to go back to the start of your question, and you don't destroy it in any way, you're actually, even though it's junk, doing some good.
Well, I'll tell you, the way to prevent your 3D printed junk from being destroyed is have children.
Right.
Oh,
they
man.
don't destroy things?
I had a box full of... I was deciding that I was going to recycle my prints, and so I was saving them all. I had a big box full of them, and eventually I realized I'm just never going to get around to it. I'm just never going to do that. So I took that box and I threw it away, and then we moved. Mm-hmm. Like, you cannot cut the line any deeper than we moved. I'm in a completely different house, and all these junk prints that I thought I had thrown away, they kept showing up. The kids thought these were their favorite toys, and they brought them with us from the old house. You can't get rid of them. Yes. They're never going away.
Yes. I know someone who moved, and they put all their stuff in storage because there was a gap between the houses, and they moved into the new house. And then their rule was that when they needed something, they'd go to the storage and get it out. And anything that was left after 6 months they hadn't bothered to get out, they were going to throw away.
Which is a good plan.
Yes, and I don't know how rigorously and religiously they stuck to that plan, but nonetheless, that was certainly what they intended to do. But there we go.
Yeah, no, absolutely. Well, you know, we've talked on the phone, or we talked before, and I know that I don't want to put any feelings of pressure on you, because I don't know, when you made the RepRap project, was your goal to change the world?
I thought it might become quite significant, or that it would die without a trace. I mean it was an academic research project, and 95% of academic research projects never see the light of day when they're finished, but that doesn't matter, because the 5% that do sometimes make a really extraordinary impact on the world. Now, I'm not saying the RepRap has yet had an extraordinary impact on the world, but at the beginning I thought, because it's self-copying, it's capable of exponential growth, and anything that's capable of exponential growth either becomes extinct or does grow exponentially. I have no idea which of those two alternatives is the one that's going to transpire, so I'll just award them a probability of 50-50 each. And it turns out that it didn't go extinct. It has spread around the world, and so it was the second alternative that turned out to be the case. So I did sort of anticipate it as a possibility, but I in no way thought it was a certainty.
Well, but that said, I feel like 3D printing has changed my life. You know, and in a positive way. I mean, not just in my YouTube channel, not just in sharing it with other people, but through 3D printing, as we discussed off camera, I've kind of started a trajectory of learning electronics and learning engineering. And I came from a mathematics and art background, and now I'm going through, and it's kind of become the gateway drug to making for me.
Yes.
In a good way.
Yes.
And to making me a more complete person. And I feel like it'll work the other direction as well. I think that when 3D printing first started, the models that I were seeing printed were very engineering, because the people who were making the 3D printers were very engineering minded. So but then somebody posts an octopus. And somebody posts, did you ever see the Gangster Model? It was
I must have missed that one.
Absolutely awful. No offense to the guy a friend who made it. But it sort of kind of looked like, maybe if you looked at it sort of sideways squinty, a person in a hoodie covered in mud.
Right.
Like, it was just no detail, but it kind of had the form of a person in a hoodie with their hands in their pockets.
Yeah.
And so they called it the Gangster Model. And in those early days, one of those models would go for days with people taking it, downloading it, remodeling it, mixing it, putting it back up, because the people who were into 3D printing there weren't artistic.
Yes.
They were engineering. So if somebody came in with something artistic, that would be their leaping off point for doing their artistic work.
I see. Yes, I see what you
And
mean.
so yeah, I think it kind of went the other. Now, of course, nowadays you have so many like professional level artists who are doing models for 3D printing.
Yes.
And it's absolutely amazing. I don't know if you know the work of Louise Diggers.
Yes. I've never met her, but I know what she does. Yes.
I hope that she's thrilled to know that you know of her work. But
Yeah, we follow each other on Twitter, so yeah.
it's gorgeous. It's gorgeous.
Mm.
And there are others like just I see and nowadays game miniatures with incredible detail that we would have never even thought of doing with injection molding. People are just pumping out all the time because we've got these 3D printers that can do it.
I mean, injection molding is a fabulous technology, but it's so economically dependent on producing 1 million or whatever it is that 3D printing is the absolute opposite, because that's so good at producing 1 or 10 offs. The two come together from very
question that people keep on asking me is, well, what's the cross point then? If this one's good for 1 million and this one's good for 1, then this one's better for 2, and this one's better for 999. At what point does it cross? And the answer is, it very much depends on the part that we're talking about.
That's absolutely true. I mean, a die for an injection molding machine, if the object you're printing, if the object you're molding,
right. Manufacturing.
If it's a sphere, if you're making a toy ball for children, then that's not a difficult mold to make. But if it's a mold which requires lots of live parts which move in and out in order to make cavities and so on, that's incredibly expensive. And so the break-even point would shift according to the complexity of the object.
Yeah, and not just the complexity of it, the size of it, and
there are still things that cannot be too complicated to injection mold that you can still 3D print, of course.
Yeah, well, and every manufacturing process has its limitations. With 3D printing, I mean, the old 3D printer, and even 3D printers nowadays that use dissolvable supports, they have practically unlimited geometry. But you take a simple RepRap with a single nozzle, and you got to think about, well, we could put supports, but then we can't get supports out of the very middle of this thing if it's too complicated.
Yes.
So there are limitations to the manufacturing process. But I think, and not objectively I'm saying this at all, 3D printing is probably the least limited.
Yes, I would agree.
Any manufacturing process.
Yes, I think that's true. It's not the fastest, certainly we talk about injection molding, but it is the one that is simply the most versatile in terms of the sheer range of geometry that it can create.
Right.
It's not the most accurate, of course. That's another aspect to it. I mean, conventional machining, engineering machining, is much more accurate than 3D printing. But often you don't need accuracy. I mean, if I can use your microphone as an example, you've got a cover over the microphone there, which is accurate to 0.1 of a millimeter or whatever.
Whatever it needs to be.
Yes, quite. If that were made by a machining process, which I find it extremely difficult to make, but if it were, that would be much more accurate. But that accuracy would be entirely spurious. It wouldn't be required for the function of the other part, or even its appearance.
Well, for the most part, and I think that there is a discussion about accuracy in 3D printing that I think we need to have more often. What happens a lot of times is when we see, hey, we got a machine that can make a plastic part, the first plastic part that a lot of people try to make is a Lego brick.
Yes.
Right?
Yes.
And there's been a little bit of hullabaloo about Lego bricks lately. The thing is, when you 3D print a Lego, depending on the 3D print, now you print it on a Prusa, it will work.
Right.
It will work with other Legos, it will work within itself, but if you print it on a cheap printer from China or a self-sourced RepRap or one of these other machines that you haven't tightened the bolts on quite enough and calibrated quite well, it doesn't fit with itself, it doesn't fit with other Legos. I've used 3D printers that can't even print a daggum circle right, it comes out kind of skewed sideways.
Yes.
And so if your 3D printer is not well calibrated, it can't print a Lego. So I'm going to say Mega Block, because Mega Block is a knockoff brand of Lego, but it fits with Legos. If you print a Mega Block compatible piece, that to me is the gold standard for can your 3D printer print
accurately.
And the other part of the problem, of course, is once you get your printer dialed in to print that Lego brick accurately, and then you change filament,
yes, then
it's going to be a little off again. You know,
that's true.
I feel like having a 3D printer that can measure the filament as it comes in and adjust the feed rate so that it's still printing out at perfect consistency is the next step. But nobody
that wouldn't technically be all that difficult, I don't think. I mean, the other thing is, of course, there's a difference between accuracy and repeatability. If you've got a machine that's not desperately accurate, but which is highly repeatable with no backlash, then you've got the possibility at least of calibrating it in such a way that it can compensate in software for its own inaccuracies.
That's true.
I had a scheme which basically allowed one. In fact, it was really simple in a way. We simply took the nozzle of a 3D printer and extruded a little bit of filament from it, and with a pair of pliers held a ball bearing with a screw hole in it of the type that's used in the Delta 3D printers for the arm.
Right.
We held the ball bearing against the nozzle and then turned the nozzle off, and of course it cooled and the plastic solidified. So we then had the nozzle with a ball bearing stuck on the end of it.
Oh, yeah.
And you could use that as a coordinate measuring machine. You could move the machine around
and have it touch down,
probe things, and probe sideways as well.
Ah.
So the idea then was to have a calibration object which consists of a stack of rectangular blocks and a top block which consists of a sort of two-dimensional series of castellations, projections sticking out. And what you do is you put the castellations on the bed of the machine, you probe all around the castellations, and that gives you 1 centimetre points in space all over the bed. You then put a 1 centimetre block underneath that and do the same thing, and you're 2 centimetres up, same thing all the way up. You've now got a complete three-dimensional map of the inaccuracies in the entire build volume of the machine. And of course, you can record that and then interpolate from that in order to correct for those inaccuracies.
Right.
As long as I say, as it's repeatable, it doesn't have to be accurate.
That is amazing.
I
think I've heard about this before, but nobody's done it.
Nobody's done it, but
Yeah.
I proposed it. I posted it on the company blog, but you can anybody can go and look it up there if they want to.
Well, and I do love how I feel like this presentation that you gave today. If they didn't record it, you should stand in front of a green screen, give the same presentation with those slides behind you, and put it up online, because I feel like more people need to hear this message as well. Maybe everything up until your presentation for a new type of 3D printer, cut it off and make that one a different video as well.
Maybe, yeah.
Yeah, I mean, it was great. It was a great presentation, but I felt like we saw two presentations. One about 3D printing is amazing and inspiring, and two about here's my idea for a next new idea for 3D printing.
I just wanted to end with something new, that's all. Because
and you gave it to a bunch of people who are now going to be thinking about it.
I hope so.
Yeah, for sure. Well,
because I really like them to do the work, not me.
Yeah, absolutely. At this point, I figure you've earned the right to say, here's the next big idea. You guys run with it. But I love how you did that with the original RepRap. And what was the quote that you said in the video or in the presentation about why you put those designs out for free? Something about
yes. Well, if you try and patent something that's self-copying, what you're saying to the world is that I want to spend the rest of my life in court trying to stop people doing with my self-copying idea the one thing it was intended to do.
Exactly.
I've got better things to do with my time, so that's why I gave it away free, really.
Yeah, but do you feel there are a lot of people who feel that open source is period full stop the way to go for everything? Do you agree with that, or do you think that there are some things that are better maybe kept within a?
I wouldn't proscribe. If people want, I do everything that I do is open source, but I'm then in the fortunate position that I, for example, can afford to do that because I have a university pension which keeps me alive, which is nice. I wouldn't stop people patenting things, for example. Though I would change patent law in a way that I can tell you if you want to know, but I will come to that in a minute. But no, if I ruled the world, which fortunately for the world, and more importantly, fortunately for me, I don't. I'd make everything open source, from bank software to military encryption software to everything, and everybody would have the source code for everything. Not necessarily the secrets that code contained, in the sense of we can encrypt things. Of course, you can keep secrets, but all the stuff that was done in the world, designing nuclear power stations, whatever, would all be open source. But but as I say,
that way
that's
other
sort of-
people could take that idea and run with it and build with it, and we could grow as a society.
Quite, yes. But equally, as I say, fortunately, I don't rule the world because here am I compelling people to do something that they may not wish to do, and that it's not really, it's not something I enjoy doing, even though I've said that that's what I would do. I'm not sure really that I would. So, no, I don't want to say we should make everything open source. I'm happy to just do that myself and for other people to do whatever they choose.
But is that,
which is why I was trying to remember the name of the authors of that triangulation
because
which I can't. I'm sorry.
No, exactly. But
Yeah.
I saw that in you. I saw that. Yeah, exactly. That's what you're in that world, and you're always thinking about that. And you think they deserve credit. And I'll tell you what, I will try when I put this video up to search for that. And if you want to email me and let me know if you can figure it out, and I'll put the link in the description so you guys can find it. Nobody will ever look at it, but it'll be there.
Yeah. Okay. I could find it in Google instantly. I know. So I'll certainly do that. Yeah.
Fantastic. Well, so you've got an idea for a new 3D printer that you want to see happening in the future.
Yes, possibly. If it'll work.
I
don't even know if it'll work.
Maybe not. But what else do you want to see happen with rapid prototyping with 3D? Do you think that we'll ever have a 3D printer in every home? Is that feasible?
Well, we don't have a conventional printer in every home. There are many more computers than there are paper printers.
That's true.
But a lot of people have paper printers. I don't know, 15-20% of computer owners have a printer, maybe more. There must be the statistic out there somewhere.
I mean, I know I've got one, so in my mind it's got to be 50-50, right?
Yeah, right. Well, that's a good default, a good null hypothesis if you don't know the answer. But yes, there isn't a washing machine in every home, which is another example I used in my talk. So there's not going to be a 3D printer in every home. I suspect that once they become more versatile in terms of what they can manufacture, particularly with multiple materials, and once they become really easy to use, as easy as a washing machine, chuck your clothes in, chuck the detergent in, press the button, walk away. Once they become that easy to use and that reliable and versatile enough to print not just the enclosure for a microphone, but the electromechanical parts of the microphone as well.
For sure.
Then I think that they will become very, very widespread indeed. Because there's no reason not to, assuming that
At
they're
that
sufficiently
point,
cheap.
yeah.
Which they probably will.
At this point, though, I don't see people making progress towards that as quickly as I would like. When I started 3D printing 7-8 years ago, the progress that I was seeing was on an upward ramp, and in my head I was like projecting that forward, and I'm like, we're going to be, but it leveled out as it does.
Yes.
And what can we do to push that? To get back into that? I don't know.
Improve the technology and make it cheaper, I suppose, are the only two things. If that happens, I mean, one of the things that surprised me that there are now a lot of multicolour machines out there.
How many of them were out there?
About 30% of the machines out there, I'm guessing. And we've had machines that will print electrical conductors, albeit not with great conductivity, has to be said, for quite a while.
Well,
now.
they're all built-in resistors.
Yeah, well, quite, yes. But I'm surprised that a lot more work hasn't gone into printing with electrical conductors, because it seems to me that even though you can get machines that will print in an insulating plastic and a conducting polymer, or a polymer with conducting particles embedded in it, or whatever.
Right.
That's a really useful thing to be able to do, to be able to print not just a mechanical device, but an electromechanical device into which, for example, you can plug chips, because you can print chip sockets just as easily as you can print a straight wire.
So basically, it'd be like taking the circuit board and building it into the design, and then just snap the individual components.
And taking advantage of the fact that you've got 3 dimensions to work in, so the routing of the conductors is not nearly so difficult as it is with a conventional circuit board, because everything can snake around in 3-dimensional space.
Wow.
And I'm surprised that hasn't received more attention and taken off more than it has, because it's essentially the same problem as printing in multiple colours.
It seems so simple. I should try that.
I think the problem is that the materials are not yet low enough. Not low enough in their resistivity.
Right.
Yes, you don't quite need something as low as the resistance of copper, but you need something that's getting on for the resistance of a metal, and I don't think we're quite there yet.
That's true.
Or if we are there, it involves having a lot of silver in the material.
It's very abrasive.
Not very abrasive going through the nozzle, but also if it's silver, very expensive as well. So the materials can be expensive.
But we don't need much of it.
No. The volume of the part, which would actually be electrical conductors, would be 1 or 2% in a electromechanical device.
Of course, some idiot is going to, once we have this conductive silver filament, they're going to go ahead and print, a table-sized chess set piece out of it or something like that. And we're all going to be going, that's not the point.
No, but they should be free to do that if they can afford to buy all that silver.
For sure. For sure. That's... Because I do have some conductive material, and that's kind of been in the back of my mind for something to do, but I've always been concerned about the abrasiveness, so I need to put a not brass nozzle into my 3D printer before I start playing with that.
Yes, that's true. And it's certainly a good idea to have a cheaply replaceable nozzle if you're going to start messing around with this sort of thing. But,
for sure. I think that's got some possibility. I should play with that a little bit myself. That sounds like fun, too. Well, thank you for making the trip all the way out here.
It's been a pleasure. Somebody else paid, so I'm happy to come.
and thank you so much for engaging with me on Twitter. And when I said, the reason why I said you should come out here is this is your legacy.
Yes, I feel you're right. Yeah.
Yeah, I like I say, I know that puts some feelings of pressure on you, and I don't want you to feel that. But at the same time, everybody out here thanks you for being the right man in the right place with the right idea at the right time.
Well, my thanks to them, because really, if I wouldn't have been able to do it on my own, and they're all carrying what I did forward, just as the people at the beginning of the project who volunteered to work with me on it for no money, just because they were enthusiastic about it. They were the people who did actually all the design and the software and everything else. I did little bits of it here and there, but they did the vast majority of the work just based on my initial idea.
It really is a community, and we all come together and lift all of us up together.
Yes, absolutely.
So, but thank you so much for being here, for spending time, and thank you for taking a couple minutes to...
Oh, it's a pleasure. I'm an erstwhile university lecturer, so you can't shut me up, really, once you point a microphone at me.
It's true, but boy, what you have to say. Thank you so much. It's been a pleasure.
Thank you.